the GRIDmeter methods are built on the original Caltrac methods and the OpenEE meter code base. And these methods provide a consistent, transparent, site-specific, weather-dependent calculation of the avoided energy use, which is commonly called savings in the energy efficiency context, for a specific customer. And this is compared to their usage in the prior year, so an existing conditions baseline. And Recurve uses the Caltrac methods and the OpenEE meter codebase to track and monitor site-specific impacts, and can also analyze them in aggregate for portfolio level payments or for targeting and other population level analytics that we're engaged in. Now, what Caltrac and the OpenEE meter do not do is isolate the relative impacts of those sites from all the other exogenous activities that are at play on the grid, like naturally occurring improvements in energy efficiency, or direct influences, even like codes and standards policies, or like we noted, the mother of all exogenous effects, which was COVID-19 and its effect on energy usage. And in order to have confidence that the impacts from these programs and intentional interventions that are felt directly by customers are something relative to the grid is really an essential forecasting activity, and it's an essential settlement activity to ensure that DERs can be seen as meaningful resources on the grid and be part of the planning process. And that's really what the GRIDmeter is intended to do. By adding in this dimension of the comparison groups, you now have a means to decipher the impact that is seen at the meter from the site level analysis and put it in relation to the trends for the whole of the grid. And as Matt noted, we used our collaborative peer testing and review processes that the GRIDmeter methods were born out of that same sort of process that we used for Caltrac and the OpenEE meter, and are now accessible for anyone to use. So we're going to step back a little bit and look at how the comparison group approach works, because that's kind of the core difference of what the GRIDmeter does. So, as I noted earlier, OpenEE meter is the foundation of calculating the changes in consumption or avoided energy use or savings, depending on the terminology that and context you're using it in. And this hourly site level regression analysis is applied for customers in both a treatment group and in a comparison group. The difference between these two values is the savings or the impacts. It's called difference of differences, but it's a fancy word as far as I can tell for subtraction. So without COVID, this would be just netting out the savings of relative routine exogenous events, good practice anyway. And it could also net out the ever-vexing non-routine event from intentional interventions like energy efficiency programs. Now with COVID, obviously, which we know is the mother of all non-routine events, that has nearly become routine as it's been persisting, it is arguably, these comparison group approaches are arguably the only way you can parse out the impact of these intentional interventions, because they're so big and there are a few other ways that you could be doing it. So that's why this selection of the comparison groups was kind of the primary objective of the research this summer, because the way you do that is foundational to how you do this difference of differences calculation. If you do it one way, you're going to get a bigger difference. And if you do it another way, then if you do it another way. So the group settled on a stratified sampling approach that really, as Matt noted, came out of political science polling. And obviously in political science polling, you need to break down the population to ensure that you're going to have a representative result. For example, different age groups have different propensity of going to the polls and voting. So you need to categorize these responses to ensure that your results are going to be reliable. For energy usage, this is accomplished through what we call binning. And by using some specific targeting feature, you can categorize customers into these different bins. This could be a customer's energy consumption, it can be their NAICS codes, their industry standard classification, or it could be other factors. But obviously energy consumption patterns are one that's an important one to this sort of analysis. And NAICS codes also prove to be a very helpful distinction to understand how different sectors were going to be performing, especially in light of COVID. In this exercise of binning, the goal is really to have a treatment and comparison group that look as similar as possible before any intervention has taken place. That's why it was so important for us to be able to do this work with MCE, because we had visibility to the entire population and we were able to look at non-participants within their population to do this testing and analysis. So all of these tests were really to look, as Matt had said, it was hard to distinguish at certain points because the results came out so tight. So let's dig into a few of those. So from the full comparison group, imagine a large sector like commercial. You have the red category, all those different dots on the left-hand side, and you start paring down by these specific parameters to create the bins, like annual usage or peak usage for the specific sector or a business category. And then with that selected sample, which is represented by the green in the middle, you can see that it's edging closer to the purple, which is the treatment group. And each of those two are much better aligned than the scattering of red, that is representing a much larger portion of the whole population. So the point being that we're getting a tighter fit that you can see visually here for this comparison. So when the intervention does happen, we have greater confidence that that intervention was the causal that intervention, the difference of differences is representing the causal effect of that intervention. So to further illustrate this, you can see in this graphic that the stratification and the binning again helps you get to a better match. So this is the hourly plots of the energy usage. The red dotted line is the full comparison pool, whereas the blue is the treatment group. And you can see that those are quite different. So without the binning, it's not looking very similar to the treatment group, which is the blue line, for any given hour of the week. Now, the other dimension of comparison, of course, is seasonality. So on this graphic with the test results, you can see that that top shoulder and the third down, which represent winter seasons, have a really tight match in all three groups. They look like nice little snakes running across the screen. But when you look at summer and the COVID season, which is the bottom line, you can see a lot greater variability between the treatment and the comparison pool. But you can see that the comparison group and the treatment group are still very tightly aligned. So this is why it necessitated having this stratified sampling and the binning strategy to build the confidence in the results after an intervention would be happening. So you'll see that the treatment and the comparison group stay nice and tight, they're binned together, and the comparison pool is doing its own thing, which is representing a much broader group of the population. Final slide. Just beyond the visual match, you can also, this one is to illustrate that indeed the statistics also built confidence that the hourly measurement is reliable, and that the difference of different savings calculations also have their own uncertainty metrics to go along with them. So the blue on the top is the stratified comparison group, and the COVID intervention period is about 3/4 away along the graphic. The green in the middle is the treatment group, and then the red line on the bottom shows the difference of differences between the two. So remember that neither the treatment nor the comparison group had direct interventions in this testing. This was all done on non-participant customers. So you can see that there's almost no error in the savings calculation, which is 0.1%. A perfect score would have been 0, but it's at 0.1%. So there's very little difference in the savings that were happening for these customers. And the other metric, the mean absolute percentage error, that MAPE, is 1.5, which this is the measure of the average error for any given hour. So some hours might have been higher or lower, but for any given hour, it was within 1.5% of the actual usage. So overall, these results indicate that these methods can be used with confidence to make hourly level measurement, and that when you do have an intervention, you can have confidence that what is reflected there is going to be the effect of the intervention and not a lot of the other things that are going on at the meter, as it were.